Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to look at two-way tables. So a two-way table organizes data collected from two different variables, usually qualitative or categorical variables, and examines the relationship between that bivariate data. When we talk about two variables, we use this word bivariate. So we're going to look at the data collected from two different variables and put them on a two-way table to be able to examine that relationship. So here's a scenario where we might use a two-way table. Researchers gather measurements from athletes and spectators at a charity 5K run and organize the information on this two-way table. So here I have two different variables. In our two-way tables, we'll put one variable, the data collected or the answers to one variable along one side, and the answers collected from another variable along another side. So here along the top, our variable is what is the position of a person at the 5K. And those people would either be athletes or spectators. So this is the position that they held at the 5K. Then along here is our other variable. So at the 5K, we took measurements from them, and those measurements were of blood pressure. And when we measured their blood pressure, we put them into two categories, either high blood pressure or normal blood pressure. So along here, the variable is what was their blood pressure, normal or high. So now that we have our two variables on the chart, then we begin to fill in the chart. And our chart should always, in a two-way table, your columns should add up. So this, the number of athletes with high blood pressure or normal blood pressure, and the number of athletes with high blood pressure should add up to be the total number of athletes. Your number of spectators with normal blood pressure and the number of spectators with high blood pressure should add up to be the total number of spectators. So here we know we had 20 total spectators. That's what that 20 tells us. And this is the total number of our blood pressure. So we had 10 people, athletes and spectators, 10 people had normal blood pressure. This too is the high blood pressure and an athlete. So we had two athletes with high blood pressure. This bottom is the total number of athletes and spectators and the total number of people who attended our 5K. So we had 30 total people that attended the 5K. We've only filled in a few of the values, but once we have a few of the values, we can fill in the rest just by adding and subtracting. So here, if I know I have 30 total people and 10 of them had normal blood pressure, if I do a little subtraction, I can find that 20 people had high blood pressure. Again, if I have 30 total people and 20 of them were spectators, then with a little subtraction, I can find out that I had 10 athletes. I had 10 total athletes. 2 of them had high blood pressure. That tells me that I had 8 people with normal blood pressure. 8 athletes with normal blood pressure. Then, if I had 10 total people with normal blood pressure and 8 of them were athletes, that means 2 of them, subtracting, were spectators. So 2 spectators had normal blood pressure. And again, just subtracting, this 20 total people with high blood pressure, 2 of them were athletes. That means that 18 were spectators. Notice that I can add up my columns and add up my rows, and it all adds up. 8 plus 2 is 10, 2 plus 18 is 20, 10 plus 20 is 30. This direction, 8 plus 2 is 10, 2 plus 18 is 20, and 10 plus 20 is 30. So my columns and rows have to add up. Then I can begin to look at the two-way table and notice certain relationships. Like, for instance, more of the people with high blood pressure were spectators, whereas my athletes had more normal blood pressure. So that's how we compare the relationship then between those two variables. So there's an example of a two-way table. In our next video, we'll continue to look at some examples of two-way tables. Math Made Simple at Simpson Math. Thanks for watching.